Hello there and welcome to Help Grow Academy. In today's class, we'll be solving over 10 most repeated post-utme questions on physics. Please don't forget to hit the like button, subscribe to this channel, and leave a comment in the comment section. The first question we have says, a car of mass 1000 kg moves around a circular track of radius 20 meters at 10 meters per second. What is the centripetal force? Option A, 2,500 newtons. Option B, 5,000 newtons. Option C, 1,000 newtons. And option D, 2,000 newtons. Now, the question says a car of mass. From the question, you were given mass. That mass is equal to 1000 kg, which is mass 1000 kg. We're also given what? Radius 20 meters. So we have radius denoted with letter R to be equal to 20 meters. They said at 10 meters per second, they gave us the velocity or speed. Let's say velocity V to be what? 10 meters per second. Now, the first step to answering any question at all is for you to know the exact topic where this question is coming from. From the question now, this question is coming from circular motion. Don't forget, when a body moves in a circular path, it requires a force directed towards the center to keep the body moving in the track. Let me cite an instance. We have something like this. This is a body. Let's say this is a body moving in a circular path. This is the center of this. A body is moving in a circular path. It requires a force pointing towards the center of this path to keep this body moving in this track. This force is called the centripetal force. Centripetal force is given by the formula F is equal to mv squared over r. This is the formula for centripetal force, F subscript C. From the question, you are given mass, which is m, we are given velocity, v, and we are also given the radius, r. If we substitute these values into this equation, we have the centripetal force is equal to mass times the square of velocity. Our mass is what? 1000 kg. Times the velocity v. Velocity is what? 10 meters per second. So we have 10. Don't forget, is what? Squared. Velocity squared. Divided by our arrow. The radius. The radius is what? 20 meters. Now, if we put our calculator, we have 1000 times 10 squared is 10 multiplying itself 2 times, which is 10 times 10. We have 100 divided by what? 20. This will give us 1000 times 100 will give us what? 100,000 divided by 20. This will take away this. We have what? 10,000 divided by 2. 10,000 divided by 2, we have 5,000. Therefore, the centripetal force is equal to 5,000 newtons. Don't forget, force is measured in what? The SI unit for force is newtons. Therefore, our correct answer here is what? Option B, 5,000 newtons. Question 2 says, a metal rod is 2 meters long at 20 degrees Celsius. It expands to 2.002 meters at 120 degrees Celsius. What is the linear expansion coefficient? Option A, we have 1 times 10 raised to the power 5 per degree Celsius. Option B, 5 times 10 raised to the power minus 6 per degree Celsius. Option C, 1 times 10 raised to the power minus 6 per degree Celsius. And option D, 1 times 10 raised to the power minus 4 per degree Celsius. Now, let's decode where this question is coming from. This question is coming from linear expansivity. The question is coming from linear expansivity. Metals expand when heated. When they expand, their rate of expansion depends on 1, the initial length, 2, it also depends on the temperature. 3, it depends on the material specific coefficient. The material specific coefficient. These are the 3 basic things that determines the rate of expansion or the amount of expansion. Now, from the question, we are given what? A metal rod of 2 meters long. So they gave us what? The initial length of the metal. Initial length, they gave us initial length of the rod to be what? 2 meters. They say at 20 degrees Celsius. So they give us the initial temperature to be 20 degrees Celsius. They say it expands to 2.002 meters. So the final length is given as what? 2.002 meters at 120 degrees Celsius. This is the final temperature. It's given as what? 120 degrees Celsius. You see, what is the linear expansion coefficient? The linear expansion coefficient is unknown. And this is denoted with what? Alpha. The initial length is denoted with what? L subscript 0. Some people call it the original length. L subscript 0. Some people use L subscript I. So for this question, let's use L subscript I since we are talking about initial length. If we had used original length here, we would have used L subscript 0. So let's work with L subscript I. We have initial temperature. This is what? T subscript what? I. Here we have final length. L subscript F. And here we have what? Final temperature. T subscript F. The linear expansion coefficient alpha is unknown. Now, the formula for linear expansion coefficient is given as alpha is equal to change in length over initial length times change in temperature. This is the formula for what? Linear expansion coefficient. From the question, we were not given change in length, but we were given initial length and what? Final length. Recall that change in length is equal to final length minus initial length, which is giving us our final length is what? 2.002 meters. So we have 2.002 meters minus our initial length, which is 2 meters. 2.002 meters minus 2 meters will give us 0.002 meters. This is our change in what? Length. For change in temperature, that is, we have that change in temperature is equal to the final temperature minus the initial temperature. From the question, the final temperature given is what? 120 degrees Celsius. So we have 120 degrees Celsius minus the initial temperature is what? 20 degrees Celsius. 20 degrees Celsius. 120 degrees Celsius minus 20 degrees Celsius gives us 100 degrees Celsius. Therefore, our change in T is what? 100 degrees Celsius. We have gotten these two values now. Let's input it into this formula to get our linear expansion coefficient. If we put these values into this formula, we have that the linear expansion coefficient is equal to change in length. Our change in length is what? 0.002 meters divided by our what? Initial length. The initial length given to us from the question is what? 2 meters, right? You have 2 times our change in temperature. Change in temperature is 100 degrees Celsius. So we have 100 degrees Celsius. This is 2 meters. Now, meters will take away meters, right? They cancel out. We have 0.002 divided by 2 times 100 gives us what? 200 degrees Celsius. Now, if we convert this to standard form, we have that 0.002 gives us 1, 2, 3. So we have 2 times 10 raised to the power minus 3. Divided, if we convert this, we move this way. 1, 2. We have 2 times 10 raised to the power 2. This 2 divided by 2, we have what? 1. We have 10 raised to the power minus 2 because this cancels out, right? We have 1. 10 raised to the power minus 3 divided by 10 raised to the power 2. From laws of indices, which is 10 raised to the power minus 3 divided by 10 raised to the power what? 2. From laws of indices, it says when two values with the same base are dividing each other, what you do is you pick one of the base and you do what? You subtract the powers. So this will give us 10 raised to the power minus 3. We pick one of the base and we subtract the power, which is minus 3 minus plus 2. This is 10 raised to the power minus 3. Minus times plus will give us what? Minus. So we have minus 3 minus 2 will give us what? Minus 5. Don't forget 1 times whatever we have here. So this is giving us 1 times 10 raised to the power minus 5. Don't forget, anything multiplied by 1 is that same thing. So if you keep your answer this way, you're still correct. Don't forget the unit here is what? Degree Celsius. So we have per degree Celsius, because the degree Celsius is in the denominator here. This is per degree Celsius. So this is our final answer. 1 times 10 raised to the power minus 5 per degree Celsius. From the options here, the correct option is what? Option A. 1 times 10 raised to the power minus 5 per degree Celsius. Question 3 says, a converging lens forms a real image of what? 30 cm. From the lens, when the object is placed 60 cm from it, what is the focal length? A converging lens forms a real image of 30 cm. From the lens, when the object is placed 60 cm from it, what is the focal length? Option A, we have 10 cm, option B, 15 cm, option C, 20 cm, and option D, 30 cm. Lenses form images based on their focal length. Lenses form images based on their focal length. The relationship between these depends on the relationship between the object distance, the image distance, and the focal length is given by the length formula, which is 1 over f is equal to 1 over v minus 1 over u. This formula is called the length formula. That's what they call this formula. 1 over f is equal to 1 over v minus 1 over u, where this v here is called the image distance, u here is called the object distance, and f is called the focal length. From the question, don't forget, let me simplify it here. The focal length this is f. V here is giving us what? The image distance. This is v. And we have the object distance, which is what? U. From the question, they gave us the image distance. They say the real image of 30 cm. So they gave us the image distance to be what? 30 cm. They also gave us something. The object distance. So when the object is placed 60 cm, so they gave us the object distance. It's giving us what? 60 cm. Now, this is the real image. This is the real image formed at the right. It is a positive. Now, the object distance is the image formed on the left side. So this is negative. If we impute this, the focal length is unknown. They say we should find the focal length. If we impute this into this formula, the length formula, we're going to have 1 over f is equal to 1 over v. 1 over, for v, we have what? It was 30. We have 30 cm minus 1 over u. For u, we have what? Minus 60 cm. This is 1 over f is equal to 1 over 30 cm. Minus times minus will give us what? Plus. So we have plus 1 over 60 cm. These are fractions, right? We'll find the LCM. The LCM of 30 and 60 is what? 60. That is 30 and 60. The LCM. What can divide these two things? There's something that can divide it. What is that? 30 can divide the both of them, right? Let's start with 30. We don't want to start with 2 and then we'll get a lot of values. Or should we do it that way? Yet, let's say the least value that can divide this is what? 2. 2 divided by 30 divided by 2, we have 15. 60 divided by 2, we have what? 30. Can 2 divide any of them here? Yes. 30 divided by 2, we have 15. 30 cannot divide this, so we bring it down. We have 15 here. Can 3 divide it? Yes. 3 can divide 15. 15 divided by 3, we have 5. 15 divided by this, we have 5. 3 cannot divide, so we move to the next value that can divide them. 5. 5 divided by 5, you have 1. 5 divided by 5, you have 1. Therefore, the LCM of 30 and 60 will multiply these values out, which is 2 times 2 times 2, 3 times 5. This is 2 times 2 is what? 4. 4 times 3 gives us 12. 12 times 5 is what? 60. So the LCM of 30 and 60 is what? 60. Now I've gotten the LCM to be 60. 60 divided by 30 here will give us 2. 2 times 1 will give us what? 2 plus the sign. 60 divided by 60 here, we have what? 1, right? 1 times 1 here gives us what? 1. 2 plus 1 will give us what? 3, right? So we have 3 over 60. Now, 3 divided by 3 here, we have what? 1. 60 divided by 3, we have 20. So, 1 over f is the same thing as what? 1 over 20. Now, we are looking for focal length and not 1 over the focal length. So, we take the inverse, which is this comes up, this comes down. We have f over 1 is equal to what? 20 over 1. Anything divided by 1 is that same value. So we have the focal length is equal to what? 20 divided by 1 is still 20 cm. Therefore, the focal length is what? 20 cm. From the options here, option C happens to be the correct answer with 20 cm. So option C is our final answer. Now question 4. This question is on projectile. It says a ball is projected at an angle of what? 30 degrees with a speed of 20 meters per second. They say find its maximum height. They gave us gravity G to be 10 meters per second squared. Option A says 5 meters. Option B 10 meters. Option C 15 meters. And option D 20 meters. Solution, let's solve this. From the question, we were given what? The angle theta to be what? 30 degrees. And they gave us speed, which is velocity, to be what? 20 meters per second. So we have velocity. Velocity to be what? 20 meters per second. Is they find its maximum height. So maximum height h is unknown. Now projectile is divided or is broken into the vertical component and the horizontal component. The maximum height is reached when the vertical velocity is equal to 0. I repeat myself, the maximum height is reached when the vertical velocity is equal to 0. So in this question, the velocity given in this question is the word vertical velocity. Now, the vertical velocity is equal to this, the velocity given from the question, which is u sine theta. If we resolve the velocity, Let's set up a free body diagram for this. It says a ball is projected at an angle of, let's say from here, this is the ball, where the ball was initially. They say it is projected at an angle of 30 degrees. So the angle of inclination is what? 30 degrees. Projectile. Don't forget, it moves this way. Now this is the ball. It is projected at an angle of what? 30 degrees. With the speed at which this ball is moving is what? 20 meters per second. So let's say speed 20 meters per second. They say what is the maximum height? The maximum height with which this ball, let's say this is the height, the maximum height. Now, like I said earlier, I said the maximum height is reached when the vertical velocity is equal to what? 0. If we resolve this to the vertical direction, that is to this y-axis, let's call this ux and let's call this uy. This is the vertical velocity and this is the what? Horizontal velocity. If we resolve this to the vertical velocity, we have that the vertical velocity uy is equal to u, which is this. We are resolving it to this place. It becomes u sine theta. That's what we have here. When we resolve it, don't forget, when it moves outside the angle, this is an angle, you bring this same value here, 30. But since it's moving outside, it becomes what? Sine. If it's moving inside, it is cos. So we are resolving to this place and it's moving outside, so it is what? It is sine. We have this to be equal to u. Our u is 20 meters per second. Sine theta, our theta here is what? 30 degrees. Now let's punch our calculator. 20 meters per second, so let's say 20 times sine 30 will give us what? 0.5. Now 2 times 0.5. 0.5 is the same thing as 1 over 2. 0.5 here is the same thing as 1 over 2. 20 times 1 over 2 gives us what? 10. Don't forget the unit remains what? Meters per second. Therefore, the vertical velocity uy is equal to what? 10 meters per second. Now we have gotten it. Let's find the maximum height h. Maximum height h is given by the formula h is equal to the square of the vertical velocity divided by 2g, where g here stands for acceleration due to gravity. H here is equal to the square of the vertical velocity. We have the vertical velocity to be what? 10, or what? Squared, divided by 2g. This is 2 times. Our g from the question is what? 10 meters per second squared. So we have 10. 2 times 10, this is 10 squared. That's 10 multiplying itself 2 times. We have 100 divided by 2 times 10 will give us what? 20. 100 divided by 20, we have what? 50. Therefore, the maximum velocity or the maximum height, therefore, the maximum height is what? 50 meters. So we note 50, this is 5. This take away this, we have what? 10 divided by 2 is 5. So we have 5 meters. Let's go over to the options here. The correct option here is what? Option A with 5 meters. Question 5 says, a resistor of 4 ohms is connected to a 12-volt battery. How much heat is produced in 10 seconds? A resistor of 4 ohms is connected to a 12-volt battery. How much heat is produced in 10 seconds? Option A, 120 joules. Option B, 360 joules. C, 480 joules. And D, 720 joules. This question is coming from electric current. Now, when electric current flows through a resistor, it produces heat. The heat generated is dependent on these 3 parameters. The first one is the voltage. That's the first parameter. The second is what? The resistance. And the third is what? The time. From the question, we are given the resistance to be what? The resistor to be 4 ohms. We have R, this is V, and this is T. We have R from the question to be 4 ohms, so we have 4 ohms. The resistance, R here, so this is for R, 4 ohms. The voltage is what? 12 volts. So we have 12 volts. The time here, T, 10 seconds. So this is 10 seconds. Now recall that they say we should find the heat produced. So heat produced is denoted with letter Q, and it is given by the formula what? PT, where P here is the power and T is the time. But recall that the formula for power for electric charge, P, is given as V squared over R. This is the formula for power for electric charge, not for work done. Where V here is the velocity and R here is the what? Resistor or resistance. For V squared, we have 12 volts, so we have 12 squared divided by our R is what? 4 ohms. 12 squared, 12 multiplying itself 2 times. 12 times 12 will give us 144 divided by 4. 144 divided by 4 will give us what? 36. Now we have gotten the power to be what? 36. And power, don't forget, power is measured in what? Watts. So we have the power to be 36. But we are not asked to look for power in this question. They say we should find what? The heat produced. Don't forget, the formula for heat produced is what? Q is equal to PT. For heat produced, Q is equal to PT. We have gotten the value of P here to be what? Power. Power is 36 watts. So we have 36 times T. From the question, they gave us T to be 10 seconds. 36 times 10 will give us 360. Don't forget, heat is measured in what? Joules. So we have Q to be what? 360 joules. This is the final answer. The correct option here is what? Option B, 360 joules.